studied by a scientist whose name was Coulomb, and gave us a law that is called Coulomb's law. Coulomb's law is similar to this, only to place. I suppose that there are two bodies, A having charge Q1, B having charge Q2, separated by a distance T. Then the force between two bodies is directly proportional to product of charges. Or you have written M1, M2. Now I replace that with the charge divided by distance ka square. Look at this same formula. The only difference here, you are writing the mass, but here you are writing with their charges distance ka square. The question is this constant. When you remove this, you get constant capital K. I don't know the value, Q1, Q2 by distance ka square. Now the problem is, what will be this K? What will be the value of K? Okay. Now the value of K is decided by the system of unit you selected. We have CGS system, we have SI system. If you have CGS system, then we take the value of K as a 1. If I get F equal to Q1, Q2 by distance ka square, then that answer will be in diameter. Charge will change, this distance will be in centimeter, Q will be in a CGS unit, that will be in time. But if I take SI system, in case of SI system, the value of K, that is given by 1 by, now listen carefully, 1 by 4 pi epsilon naught epsilon r. This is pronounced as EPSILON, epsilon naught epsilon r. But what is epsilon naught? It is epsilon naught is called absolute permittivity. And what is epsilon r? Epsilon r is called relative permittivity. The value of these, this is also called sometimes dielectric constant. The value of this epsilon naught, epsilon r is given in the question. Now you know that value of G 6.6 10 so, and the similar with the value of this epsilon naught is given 8.85 10 to minus 12. With its unit, that will be Coulomb square, Newton inverse m minus 2. This is the value. It's a fixed value, epsilon naught key. But epsilon naught, that depend upon medium, or pani mein ho, hawa mein ho, which medium is between the two charges, that is decided by this. It means if I go for SI system, so force is given by 1 by 4 pi epsilon naught epsilon r, first charge, second charge divided by distance ka square. Now this is for the two cases. In case of air or vacuum, the value of epsilon r is 1. In case of air or vacuum, the value of epsilon r is 1. It means if I get in air, the formula becomes 1 by 4 pi epsilon naught. First charge, second charge divided by distance ka square. Force in air, now all values you know that 4, what is the value of pi? 3.15, value of epsilon naught is value of 8.85 10 to minus 12. First charge, second charge divided by distance ka square. Take the help of calculator, scientific calculator. When you solve, you get its value comes out to be 9 into 10 to power 9. First charge, second charge divided by distance ka. This is the formula that I will use in all the numericals. When you solve the article, then you will write the force in air is given by 1 by 4 pi epsilon naught Q1 and Q2 by distance ka square. In some books, it is written that force in air is small k, Q1, Q2 by distance k. If it is small k, it is obvious that its value is 9 into 10 ki power 9, or it may be 1 by 4 pi epsilon naught. But when I solve the numericals, I will put direct, I can put the value of direct as value of k is 9 into 10 is to power 9 q1 q2 by distance ka square. This is the method to solve. This is my important formula which I will use in solving all the numerical. But this is the case air or vacuum. But we have written there are maybe some medium between the two charges. The previous case was Q1, Q2, and between these two charges there is air or vacuum. But now the question, if there is a medium, then value of epsilon naught, this is called dielectric constant. Dielectric constant will be given to you. Now the formula in case of medium becomes, yes, 4 pi epsilon naught as it is, multiply by, so in previous case value was 1. First charge, second charge divided by distance ka square. So force in medium is equal to, if you see this, look at this. This formula is similar to the previous. So this becomes force in air divided by epsilon r, my important formula. It means my force between the two charges depend upon the medium. It is not as case of gravitation. In case of gravitation, whether you are inside the water or you are in some other medium, air or vacuum, the gravitation formula is gm1 m2 by distance square. It is independent of this. But in this case, my force depends upon the medium too. If I change the medium, definitely, I just gave you question. That question was in CBSE. I don't know the year. The question was, there are two charges Q and 6Q separated by some distance and the force between them is F. Now a cardboard placed between these two charges, what will be the new force between these two? Sorry, what will be the new force? Now this was a 1 mark question. We have not given what is the dielectric constant of that car, but always remember, since there is some medium between two charges, the force 101